ChatGPT is once again making headlines with the release of version 4, which has been absolutely crushing a bunch of standardized tests. So today I want to put it to the test specifically with software engineering. So I'm going to give it a variety of different software engineering tasks and compare it to how I think a human would do and compare it to the previous version of ChatGPT. So the way I'm going to do this is by starting with some coding interview questions, because after all, we all have to pass coding interviews to become software engineers, so we should hold ChatGPT to the same absurd standard. And then after the coding interviews, I'll give it some more practical, actual software engineering tasks to see how it does on that, as well as some debugging, see if it's able to debug code. And finally, I'll also test it on its knowledge of computer science. So for the coding interviews, I'm going to get them from Algo Expert. We'll do 10 of them, starting with some easies and then moving up to some hards and very hards. So the first question is validate subsequence. It takes in an array and a sequence, and it needs to tell us if that is a valid subsequence of the main array. So I'm going to paste the entire prompt into ChatGPT, as well as I'll switch to GPT 3.5 to begin with, so the old version. And we can see we have the prompt here, and I added this little bit at the beginning with some context. So essentially, you're doing a coding interview in Python. Answer the following question by only providing correct, efficient Python code. And you do not need to explain the code, so I don't want a bunch of extra text, but then give time and space complexity at the end. So let's go ahead and run this. And one thing I have noticed is with the Pro subscription, GPT 3.5 runs almost instantly, which is super cool. So it's way faster. So it says time complexity O of n, space complexity O of 1, and we have some code here. So let's copy the code into here, paste it, and we can simply run our code. And it did actually pass all of the test cases. So 24 out of 24 test cases correct. And now I will open up a brand new chat, and this one will be with GPT-4. It will paste the exact same prompt in, and we'll see how it does in comparison. So it is going to take a little bit longer. So GPT-4 is not as fast as GPT 3.5, but supposedly it does a better job. One thing I'm noticing here is it's using very strange formatting. It doesn't have the code formatting, and then the time and space complexity is absolutely massive, but they are still correct. So let's go ahead and paste this code in. And it didn't actually indent it for me, so I'll just go ahead and indent it for it, which I don't know if we should take some points off for this, but it is, I believe, still correct. So we can run this code, and we do still pass 24 out of 24 test cases. So both of them were able to pass this, although GPT-4 did format it kind of strangely. Okay, so I'm going to give it 9 other coding interview questions, collect some data, and I'll check back in. All right, so here is the data. Actually, they performed almost the exact same, which was interesting. I've seen some other data that people have shown on Twitter and whatnot, where GPT-4 is doing much better than 3.5 in the coding interviews. But at least in my small test, they did basically the same. If they got the question incorrect, I gave both of them the chance to do it again. And in any of the cases where they got it incorrect, actually both of them were able to correct their solutions in every single case. So ultimately, all 10 questions they were both able to get correct, which is interesting because the last time I tried to do coding interview questions with GPT 3.5, it was actually not doing a very good job at them. So I don't know if I got better at that or if I just got lucky, but in my small test, they both did basically the exact same. They did, however, struggle a little bit with time and space complexity. Some of the problems I gave it were just sort of difficult, though. For example, one of them had a factorial in the space complexity, and neither GPT 3.5 or GPT-4 was able to figure that out. Also, as far as the formatting bug, it seems to be a bug on the actual website. It's happening with both models. So whenever the formatting's messed up, I'll just fix the formatting and we'll assume it did that correctly. Okay, so now what I want to do is test it on some more practical coding. And what better way to start some practical coding than seeing if it can do the age-old hardest thing to do in all of computer science, and that, of course, is how to center a div. So how do you center a div? And we'll start with GPT 3.5 and see what it says. Okay, so to center a div horizontally, you can set the margin property to auto and specify a width for the div. So I guess this does work. I don't love that it did it inline in HTML, but I guess I didn't specify otherwise, so that is fine. In the example above, the div has a width of 50%, which means it will take up half the available space. The margin is set to 0 auto, which means that the left and right margins will be set to auto, centering the div horizontally. Okay, so that seems correct. If you want to do both horizontal and vertical, you can do display flex. So we have div, style, display flex, align item center, justify content center. This is a center div. So this is correct, although it doesn't necessarily center the div, it's centering the content within the div. So it's like this explanation down here is correct, but it's not really centering the div itself. I would want to see that as like a wrapper around the div. But either way, I'll count this as correct. Let's move on to GPT-4. Okay, so the GPT-4 answer took like 5 minutes to generate. I kept getting network errors and all of that, but I'm not going to hold that against the model. And the answer actually seems much better. So to center a div, we have some different options, and it did actually write CSS for us instead of doing it inline, which is nice, but again, it's not really what I asked for, so either way is fine. So to center a div horizontally using margin, we have margin left and right as auto. The display block is a little bit strange because a div, it should know, already is display block by default, but that is, I guess, fine. It's not going to do anything incorrect. And then we have our HTML with the content in the middle, and this would be centered. And then we have using Flexbox, and it did this, I think, much better than GPT 3.5. So it actually recognized in the HTML that we need a parent div and this centered div inside. Again, 3.5 sort of hinted at this in the writing it had after it, but in the actual code, it didn't do that. So here we have nested divs, which is what you really need with Flexbox. And then we also have a grid solution, which we did not get from 3.5. So this is a little bit more complete, a little bit less concise, I guess you could say. So here we have a parent with justify items center and align items center, and it gave it a height as well. And this is display grid, and this should also work to center this div here. And then finally, it also gave us a transform property solution, which also, I guess, works. So here we have position absolute, top and left 50%, and then we translate negative 50% in both directions, which would also work. And then we have the same centered div inside of its parent. Okay, so next I want to do something sort of fun. I want it to be a little bit creative while also writing code. So what I'm going to do is ask ChatGPT, starting with 3.5, if it can write HTML and CSS code to create a cartoon pig and to give us just the completed code. And I'll go ahead and copy and paste this code into a browser, and I'll put it up here so you all can see what it looks like. Okay, so as you can see here, the CSS it wrote basically doesn't work. Most of this doesn't really look like a pig. It sort of had the right idea down, but the execution was just a little bit off. So let's copy this prompt and move over to GPT-4, paste this same prompt in. I don't need my name there. And we'll see if ChatGPT-4 does an even better job. Okay, so we got the answer back from GPT-4 as well. I'll put it up here. I guess we can debate as to which one's better. I would argue the GPT-4 one got a little bit closer, although it looks sort of demonic. It's a little bit scary to look at, but I do think GPT-4 did a slightly better job with this one, but neither one was able to really blow it out of the water. But that said, it was a pretty hard challenge. Okay, so now we actually have similar questions to this on Frontend Expert for CSS practice. So for example, this one, you need to make this cartoon robot emoji thing. So what I'm going to do is give this to ChatGPT, the entire question, and see if, given a little bit more structure, if it's able to generate the CSS for this. So first of all, let's start with GPT 3.5. So I'll paste the entire prompt in here, and we'll see how it does. Okay, so we got the GPT 3.5 answer back. So here we have all of the different code, and it also gave us the HTML back. I'm not entirely sure why it did that, but that's fine. The HTML is unchanged, and we can copy this over here, paste it, and it got pretty close. It's not correct, obviously. If I submit this, it's not going to be correct, but it did get pretty close. So let's see if GPT-4 is able to get closer than 3.5 was. Okay, so GPT-4 again took a while to actually generate, but we did get some CSS. So what I'm going to do is copy this CSS, come over to our robot emoji on Frontend Expert. We can see the GPT 3.5 solution. Let's come to solution 2, paste in the GPT-4 solution. It looks like it got closer. So if we toggle between these, you can see solution 1, which is 3.5, and solution 2, which is GPT-4. Neither of them are correct. If I run this, it's not going to pass, but it is much closer. Okay, so now I want to test ChatGPT a little bit on some JavaScript, and I'll use some JavaScript interview questions for that from Frontend Expert. So first we have this promises question, which essentially is to implement promises as a new class without using the built-in promises class. So I will paste the entire thing in for ChatGPT 3.5, and we are getting a solution already. It looks like we are getting that bug where some of it is highlighted and some isn't, but I'll fix all of that and get it pasted into Frontend Expert. Okay, so after much struggling with GPT 3.5, I did finally get it to give us the code all at once. So let's copy the code into Frontend Expert. Make sure not to delete the export at the bottom. I'll also delete this sample usage it gave us because we don't need any of this. And let's see how it does. Okay, so it passes 16 out of 18 test cases, so that's not bad at all. I mean, it's not passing all of them. Let's go ahead and try giving it one of the failed test cases. So I'm going to paste this entire test case into ChatGPT. So say it failed this test case, and then I'll just pass in the entire test case and see if it is able to fix the code. Okay, so it did generate some new code, but I also pasted it into Front-End Expert, and now we're actually only passing 6 out of 18 test cases. So it wasn't able to debug its own code, but 16 out of 18 to begin with is not terrible. Okay, so GPT-4 was also able to complete, and it gave us a very similar, almost the exact same solution as GPT 3.5. I pasted it into promises on Front-End Expert and fixed the indentation, and it actually fails the exact same test cases. So you can see 16 out of 18, and we get these same failures. So I'm going to give it the exact same prompt, and maybe GPT-4 will do a better job of debugging itself than 3.5 did. Okay, so it took a while to generate, but we did get all of the code together again, so that's nice. So we'll copy this code. Let's go to solution 3, paste this in, and I think I deleted the export, so we can say exports.myPromise equals myPromise. Run this code, and it looks like now we passed 5 out of 18 test cases, so we're doing even worse than GPT 3.5 did at debugging. So neither of them was able to properly debug their failed test cases on this problem, but it is a very hard problem. So not the end of the world, but they were not able to solve it. Okay, so for a point of redemption, what I'm going to do is give both GPT 3.5 and GPT-4 a bit of an easier JavaScript question. So we're going to give it debounce, which is a very classic question. It's not easy by any means, but it's not super difficult either. So starting with 3.5, let's paste the prompt in here, and we are getting a debounce function very quickly this time. So I will copy this code, and let's go ahead and paste it right here. Run the code, and we passed 10 out of 14 test cases. So not terrible by any means, but it did a decent job. So once again, what I'm going to do is give it the test case that it failed and see if it's able to debug itself based on that failed test case. And let's go ahead and copy this code, and I will paste it in here. I'll paste it as solution 2, see if it does any better. Run this code, and we get 7 out of 14. So once again, trying to debug based on a test case, and it actually ends up doing worse, not better. Okay, so GPT-4 once again had the bug where it's a little bit hard to read the code. However, I did go ahead and paste all of that code into Front-End Expert. You can see when I ran this code, we actually do pass all 14 test cases. So this is the first case I've seen where GPT-4 was able to perfectly solve a problem, and GPT 3.5 was actually not able to solve the problem even after I told it what it did wrong. So that's a big win for GPT-4, but now what I want to do is see if we can do something that I did in my first video I ever did with ChatGPT, and it was giving me a big headache, and that was trying to create a tic-tac-toe game. So I'm going to paste this prompt in here telling it to create a tic-tac-toe game for us using HTML, CSS, and JavaScript, and we'll see first if GPT 3.5 can give us a game we can play, and then we'll see if GPT-4 can give us a game we can play, and maybe it'll be a better game. Okay, so GPT 3.5 told us, unfortunately, as an AI language model, I'm unable to provide the code as I don't have the capability to create files or execute them. And then it says, however, I can provide you with an example of the code that you can use as a starting point. So I guess maybe it's saying it can't do everything, but it's giving us sort of a starting point. So we have HTML, CSS, and then JavaScript, but it did do that thing where it didn't completely finish. So what I'm going to do is just say continue and see if it's able to give us the rest of this code. And it does look like it did that. So I'm going to go ahead and paste all of this code together and see if we have a working game. Okay, so this is the game that GPT 3.5 gave us. The CSS doesn't seem to work. We don't really have a grid. We just have a big row, but it does say it's X's turn. So let's try clicking, and we do get an X. Now it's O's turn, so we'll click there. X's turn. So this part does seem to be working. I'm not really sure how to win because I don't know what this grid represents, but it says X wins. I don't know if X actually won there or not, but let's go ahead. Reset does seem to work. So let's try doing something like this. Does that make X win? It does. Okay, so the game does seem to work. It just seems like the CSS is broken, but this is a big win over what happened the first time I tried to get tic-tac-toe out of GPT 3.5. Okay, so GPT-4 was able to finish. Again, we got that bug where it sort of is just giving us the code without proper formatting, but it gave us a bunch of code. It wrote it all in HTML and used like a script tag and a style tag, but that's perfectly okay. I pasted it into a code pin, and at least stylistically, it looks much better than what we had before. We do have a grid that looks like tic-tac-toe. So let's go ahead and click, and we do get an X. If I click here, I get an O, X, O, X, and now we get player X wins. So that does seem to be working. Let's let O win real quick, make sure that works as well. And that also seems to be working. Can we win diagonally? And we can. So it does seem like this tic-tac-toe works perfectly. So awesome job to ChatGPT-4. This is much better than 3.5 gave and way better than we got the first time I ever tried to do this. Okay, so next what I want to do is see how it can do with DOM manipulation in JavaScript and see if it can make an API request to an API if I describe it to it. So what we have here is this infinite scroll problem that we have on Frontend Expert, where you have to make an infinitely scrolling container of testimonials. So I'm going to paste the prompt into GPT 3.5 first of all, and see how it is able to do. Okay, so once again, we got an answer super quick, and we have proper formatting, so woohoo on that one. So we have all of the code here. It looks pretty good at first glance, and then it did give us an explanation below, which is nice. I didn't ask for an explanation, but it did give it to us, so that is cool. And we can come in here, paste the code, and let's see how it does. Okay, so we did properly fetch testimonials. However, it doesn't seem like the infinite scrolling is actually working. As I scroll to the bottom here, we do not seem to be fetching more. So it's getting close, but it is not completely working. It passes 4 out of the 10 test cases. But let's go ahead and see if it can actually debug itself. So I'm going to say this loads the initial testimonials. However, it does not load more on scroll. And let's see if it is able to fix itself. Okay, so I apologize for the mistake in my previous answer. You are correct. The code I provided only loads the initial testimonials and doesn't load more on scroll. Here's an updated implementation, and it looks like this is complete now. So let's copy this code, come over here, and paste it in. And let's see, in the browser output, are we able to infinitely scroll? We still are not, so it wasn't able to fix its mistakes, and again, we get 4 out of 10 test cases passed. Okay, so GPT-4 was able to actually finish pretty quickly this time, and I like the way it sort of formatted this answer, so it told us in steps what it's going to do, and then it gave us the code. So let's copy the code it gave us. We'll go to solution 2 here, paste in the code. Let's see the browser output, so we do get the initial testimonials, and as we scroll, again, we're not getting more, so I suspect we're once again going to get 4 out of 10 test cases, and again, we do. So I will do the same thing with GPT-4. I'll tell it it doesn't work on scrolling and see if it's able to fix itself. Okay, so GPT-4 just got back with its corrected solution, and it said the issue was that the scroll event listener was on the window object instead of the testimonial container, which seems like a valid issue. So let's copy this code, come back to Frontend Expert. I'll paste this into solution 3. Let's check out the browser output tab. And this does seem to be working, or at least working better. Let's run the code. And 10 out of 10. So GPT-4 was actually able to correctly diagnose the issue and fix its code, whereas GPT 3.5 initially had basically the same incorrect code, but it was not able to fix itself. So much better on the GPT-4 side. Okay, so next I want to test some React knowledge. So we're going to start with a React hook. So we have this question, use state with history, which is a pretty classic React hook. So let's go to GPT 3.5, paste in the question, and see if it's able to write a use state with history hook. And it seems like it's doing it very quickly. Okay, so now we have our hook. We have some explanation here as to how it supposedly works, but let's see if it actually works. So I will paste this into here, and we can run this code. And 0 out of 12, I think we just need to delete this export default, run this again, and we get 11 out of 12 test cases passed. Okay, so as we did before, I went ahead and gave it the failed test case. Let's copy this code, come back here, and we will update this to see if it is now working, and we will remove that once again, run the code, and still we get 11 out of 12. So it gave us different code, but it's still failing the test case. So again, GPT 3.5 isn't doing a great job of debugging when I give it the test case that it's failing. Okay, so GPT-4 just gave us the code. It didn't really say much for an explanation. Let's go ahead and copy this into here. So we have use state with history. We can run the code and failed 1 out of the 12 test cases. And it looks like it failed the same test case as GPT 3.5 did. So again, we get the same results initially. But let's see if GPT-4 does a better job of debugging itself. Okay, so GPT-4 is confidently telling us that it has a correct answer now. So let's go ahead and copy this, and we can paste it in here and see if this updated version actually passes. And it does not, so it still fails test case 11. So both of them weren't able to debug in this case, but they did get pretty close regardless. Okay, so now what I want to do is see if we can get an entire React application written for us. So I'm going to ask, first of all, GPT 3.5 to create a Connect 4 game using React, and we'll see if we are able to play this game. Okay, so I've been trying with GPT 3.5 for a while, trying to get it to debug its own code and just sort of regenerate itself a few times to get Connect 4 working. It's given us some code that looks pretty close to valid, but no matter what I've done, it's not been able to actually give us working code. Like, it doesn't even work a little bit. It has syntax errors in it, and it's not even really close to working. Granted, this is a big thing to try to ask it. It's trying to build an entire sort of application, but the GPT 3.5 version is effectively something I wouldn't be able to use at all. Maybe I could ask it for small components at a time and then put them all together and get it to work. But the just asking for Connect 4 outright with React is not working at all on GPT 3.5. Okay, so GPT-4 seems to have done a bit of a better job here. So what it did is it actually gave us instructions on how to make an entire application. So at first, like, even told us to go to create React app and what files we need to edit and where to put them. It broke it all down into different files for us. It did sort of run out of space like it does sometimes, so I had to do it by a little continue. And when it did the continue, it was sort of a mess. So I got it to give us all of the code back together, which it was able to do. So I went ahead and made a code pin with it. And this seems much better than what we had before. The CSS at least is working. So let's see what happens when we click. So let's say we play there. We get red shows the middle. Let's say there. Yellow shows the one next to it. So it seems to be working. Let's see if we can actually win the game. Okay, so winning the game doesn't seem to actually do anything. Okay, so it's actually Connect 5 instead of Connect 4, but that is pretty close to actually working. So definitely this one goes to GPT-4 over 3.5. Let's see if we can play again also. Okay, so it seems like we can even play again. Let's see if we can let yellow win horizontally. We can't, but maybe that's because it needed 5 in a row. Okay, so it doesn't perfectly work because player 2 should not have just won, and it says it did, but this is much closer than GPT 3.5 was. Okay, so now I want to shift gears a little bit away from actual coding and see if I can do some of the other aspects of software engineering and computer science, starting with system design. So let's ask it to make a system design for an infinitely scrolling newsfeed similar to the Facebook newsfeed. Okay, so we have our answer. So first it just tells us what infinite scrolling is. This is fine. And then it gives us a high-level overview of a system design. So it tells us we need a database to store all of the content for the newsfeed. It doesn't tell us what type of database we need, but maybe we could drill down on that by asking more questions. Then it tells us we need content retrieval. So this is a way to actually retrieve information from the database, which makes sense. It tells us we can use caching, indexing, and sharding to improve performance, which would be important. Then we need a content ranking system. The system should have a mechanism to rank content based on relevance, popularity, and other factors. So I would agree with that. It says we can use machine learning or a rules-based system, which makes sense to me, and it should be updated regularly to reflect changes in user behavior and preferences. And then we have the actual infinite scrolling part, which seems good to me as well. Then we have user engagement, which is basically telling us we should have likes, comments, sharing, things like that. Then we have personalization. So we need some way to personalize settings. And then we have scalability. So the system should be designed to handle a large number of users and a high volume of content. This can be achieved by using scalable technologies such as cloud computing, distributed databases, and load balancers, as well as by optimizing the system architecture for high availability and fault tolerance. So overall, I would say it gave a good answer. Everything it said seemed to be correct to me, although it didn't go super in-depth in anything. But that said, I'm sure we could drill down on all of these details if I asked more questions. So not a terrible answer, not the best answer I've ever seen either. But let's see how GPT-4 does instead with the exact same question. Okay, so now we have an answer from GPT-4, and let's see how it compares to that of GPT 3.5. So first it tells us we need, for the front end, some UI components, and it tells us what components to implement, which is already, I think, a really good step. And then it tells us we need an infinite scroll. So this is going to be a scroll event listener that triggers a function to fetch new content when the user reaches a certain scroll position. So perfect. Then it says to implement pagination to fetch content in chunks, e.g. 10 posts at a time. And it says to use debouncing to prevent multiple fetches in a short amount of time. So from the front end side, this seems pretty much perfect to me. And then we have the backend, and it tells us API endpoints first of all. So we have a fetch post endpoint, which is an endpoint for retrieving a batch of posts based on users' interests, friends, and pagination parameters. So that sounds good. And then fetch additional post data to get data such as comments and likes for a specific post. So both of these seem incredibly reasonable to me. And then we have data models. So first we have a user to store information about the user. We have a post to store information about the post, and a comment. And then it tells us we need an algorithm and ranking as well. So it says to implement an algorithm to rank and prioritize posts based on factors such as recency, relevancy, popularity, and the user's preferences, and periodically update the ranking algorithm based on user feedback and engagement metrics. So it's very similar to the algorithm that was described in GPT 3.5. And then we have a database. So choose a database system that supports efficient retrieval and sorting of data, design an appropriate schema to store user, post, and comment data, and implement indexing for faster querying and sorting of data. I like that it gave us a little bit more information about the database here and how to choose the correct type of database, even if it didn't go super in depth with any specific examples. And then we have caching. Implement caching on the front end to store recently fetched posts and minimize the need for additional API calls. So that's great. I think that's very important. And implement caching on the back end to store frequently accessed data such as popular posts or user information. Also, I think great. Then we have monitoring and scaling. So monitor the system's performance and load to identify bottlenecks and potential areas for improvement, and optimize the system for performance and scalability by employing techniques such as load balancing, database sharding, and content delivery networks. And then we have security and privacy, which I don't think the other answer touched on at all. So implement authentication and authorization mechanisms to protect user data and ensure only authorized users can access certain content, and regularly review and update the system's security measures to safeguard against potential threats and vulnerabilities. Okay, so I think both of these answers were reasonable. It seems like GPT-4 went more in depth. I'm not sure how much that is due to GPT-4 being more advanced versus it's just that maybe GPT-4 is programmed in ChatGPT to give us more depth in the answers versus GPT 3.5 seems sort of focused on speed. But regardless, this was a more in-depth answer, but I think both answers were reasonable and a good starting place that you could use to drill down in those details. Next, I want to test some debugging. So what I'm going to do is paste some Python code in here that actually has a bug. So this is supposed to be an in-order traversal. However, it does not work. And essentially this does not work because of the fact that we do not have the base case at the very beginning. And let's see what it says. So the code you provided for the in-order traversal of a binary search tree is not correct as it lacks base cases and initial checks. So that's exactly correct. It will fail with an error if it is called with an empty tree, as there will be no tree.left or tree.right to traverse. Here is a corrected version, and that is completely correct. So it perfectly realized that this code was incorrect, so I didn't tell it it was incorrect. If you read this prompt, all it does is say, is this correct? And if it's not, fix it. And it was able to perfectly identify the issue. So I would imagine GPT-4 will also be able to do this. But let's go ahead and try that now. So we can switch to GPT-4, paste the same prompt in, and we'll see if it gets it correct. Okay, so GPT-4 was also able to perfectly identify that the code was not correct, and it gave us basically the exact same answer. So now I want to do one more debugging test. This one is actually going to use Java, and the issue here is that we would get an index out of bounds error. So let's see if it is able to fix it. This is GPT 3.5. The code is not correct. So the for loop has an off by one error. The condition in the loop, I is less than or equal to nums.length, should be I is less than nums.length. This is correct because arrays in Java are zero-based indexing, meaning that the last element in the array is at index nums.length minus 1. So this is correct, and it also tells us the correct error we would get, and it was able to fix the code. So GPT 3.5 did a great job of debugging here as well. Okay, and GPT-4 also gave basically the same message. So both of them are able to debug pretty simple code. We did see earlier that GPT-4 seemed to do better in debugging overall, but at least in these simple examples, they both were able to do it. Okay, so now I want to test its knowledge of computer science. So I'm going to give it 5 different computer science questions and see if they are able to answer all 5 of these questions. So the questions are to explain how the internet works, how computers work, what the differences between a compiler and an interpreter, what different programming paradigms are, and what public key encryption is. So first, how the internet works. The internet is a vast network of interconnected computers and devices that communicate with each other using standardized protocols. When you send information over the internet, it is broken down into packets and sent through a series of routers, which direct the packets to their destination. The information is then reassembled at the destination computer or device. This process happens very quickly, allowing you to access websites, send emails, and communicate with people all over the world. So a basic explanation, but that is correct. How do computers work? They process information through a series of electronic components. These components include the central processing unit, memory, input-output devices, and storage. The CPU is the brain of the computer and responsible for executing instructions. Memory is used to temporarily store data and instructions that are currently being used by the CPU. I/O devices, such as keyboards and monitors, allow users to interact with the computer. Storage devices, such as hard drives and solid-state drives, are used to store data and programs for later use. So again, very basic level, but this is correct. What is the difference between a compiler and an interpreter? A compiler and an interpreter are both programs that translate code into machine-readable instructions. However, they work in different ways. A compiler takes the entire source code and translates it into executable code in a single step. The resulting executable code can be run directly on a computer. In contrast, an interpreter translates source code one line at a time, executing each line as it is translated. This allows for a more interactive development process, but can also be slower than using a compiler. And different programming paradigms, it gave us procedural programming, object-oriented programming, functional programming, and event-driven programming. And these all seem like reasonable answers as well. Then we have public key encryption, which is a cryptographic technique that uses two different keys to encrypt and decrypt data. One key, the public key, is freely available and used to encrypt data. The other key, the private key, is kept secret and used to decrypt the encrypted data. Because the private key is never shared, it provides a secure way to send and receive sensitive information over the internet. Public key encryption is widely used for secure online transactions, such as online banking and e-commerce. So none of these answers were in-depth by any means, but they were all, for the most part, correct. But let's see if GPT-4 gives us a more in-depth answer and gives us some extra information. Okay, so now we have the GPT-4 version as well. So how the internet works, it seems like this paragraph is roughly the same thing. It tells us that it's a global network of interconnected devices, but then it also gives us information about the internet protocol, the transmission control protocol, and how that's working. So it doesn't just tell us that packets are being sent, it tells us sort of a little bit about how that's happening. And then it mentions HTTP as well as FTP, so it does give us just a little bit more information than we got from GPT 3.5. Next, we have how computers work. So a computer is an electronic device that processes data following instructions given by a program or software. The CPU is the computer's brain, responsible for executing instructions and performing calculations. Memory, such as RAM and storage, holds data and instructions for the CPU. I/O devices, keyboard, mouse, allow users to enter information, while output devices, so a monitor or a printer, display the results of processing. Software, including operating systems and applications, provides the instructions needed to control the hardware and perform tasks. So again, I'd say both answers were correct, but I think this one was just a little bit more in depth. Then we have the difference between a compiler and an interpreter. A compiler and an interpreter both are tools used to translate high-level programming languages into machine-readable code. The main difference between them lies in their execution process. And it seems like both of these gave roughly the same answer on compilers versus interpreters. And then we have programming paradigms, which are approaches or styles used to structure and organize code. Some common ones include imperative, object-oriented, functional, and logic. And then it gave us some examples of each. And then we have public key encryption, which it tells us is also called asymmetric encryption, is a cryptographic system that uses two separate keys, a public key and a private key. The public key is freely shared and can be used by anyone to encrypt a message, while the private key is kept secret and used to decrypt the message. Then it roughly tells us how these are used, and it says public key encryption is widely used in secure communication protocols like SSL and TLS, which protect data transmission over the internet, and in digital signatures to verify the authenticity and integrity of messages or documents. So overall, again, not a super in-depth answer, but I think a good one at that. So I'll leave it up to y'all as to which one you think did better on the computer science questions. I think both did fairly well. And overall, I would say that both GPT 3.5 and GPT 4 did pretty well on most of these tests. It seemed like GPT 4 was able to give a little bit more detail in all of its answers, as well as its code was generally a little bit better. But for the most part, both of them did almost the exact same on all of the coding tests. But that said, I have seen a lot of examples online where GPT-4 has far outperformed GPT 3.5 in some coding tests, so your mileage may vary there. And there's also the difference of GPT 3.5 seems to work about 10 times faster. It's nearly instant, whereas GPT-4 takes a while to get the answers back. Either way, it does seem like a big progression, and overall, I don't think we're at the point where GPT is anywhere near replacing software engineers, but at the same time, it is very good at software engineering, and it can be a useful tool that you can use to assist you in your own software engineering job. So with that said, that is going to be the end of this video. If you enjoyed it, make sure to subscribe for future content, and I will see you next time.